Okay, so this is a problem from Alex, and it says some measurements on the initial rate of a certain reaction are given in the table below. And so it's pretty much, we're going to be using a method of initial rates here. So that's what's going on. So we're looking for we've got two reactants. So the rate is going to be of the order of rate equals K H2 to the M I2 to the N, and our question is asking us what is M or what is N. So I'm looking for two reactions where the H2 varies but the I2 stays the same. So that's going to be the first two as I've indicated there. And then I'm looking for two reactions where the H2 stays the same but the I2 varies, and that's going to be reaction 1 and 3. So let's go on ahead and figure out the order with respect to H2. So M will be equal to the log of the rate in reaction 1 over the rate in reaction 2 divided by the log of the concentration of H2 in 1 over the concentration of H2 in 2. So put all of that into my calculator. It's the log of 0.303 over 0.0961 divided by the log of 1.91 on 0.606. So when I do that, I'm going to get my M value. Why don't I just write it up here? M equals, and we'll see what we get. It's commonly like a whole number, but it doesn't always have to be, and it's commonly a positive number. Log 0.303 divide 0.0961 divided by log of 1.91 divide 0.606. That equals that, and I got 1. So it's first order with respect to hydrogen. So now I've got to go on and do the same thing for I2, and I'm going to use the reactions 1 and 3 to do this. So my N value will be log of rate 1 over rate 3 over the log of the concentration of I2 in 1 over the concentration of I2 in 3. So N's going to be log of, and what have we got here, 0.303 over 0.985 divided by log of, we've just got to like not get things confused, 0.139 over 0.452. See what we get. Okay, so log of 0.303 divide 0.985 close parentheses divide log of 0.139 on 0.452 close parentheses, and I ended up getting like, it was like 0.9997, so it's also first order in I2. So I can kind of go on now and use this information to get the rate constant, which is what I'm being asked to enter here. So what I need to do is I need to correctly enter the rate law. So it's going to be rate is equal to K H2 I2. It is first order in both of those things. So that's going to go into there, and I just want to enter that in correctly. And then now I want to reorganize this guy and get the rate constant. So the rate divided is going to be divided by H2 divided by I2. Don't forget to put it in parentheses. That's going to give me my K. You can pick any experiment to calculate this, but my recommendation is I always normally do the first experiment. Don't know why. So it's going to be 0.303 divided by 1.91 times 0.139. That'll give me my K. And I put that into my calculator. I'm not going to round it all. It's obviously going to be 3 sig figs that I want here. 0.303 divided by 1.91 times 0.139. And I got my K, 1.14 to 3 sig figs. It tells me to give it to 3 sig figs, so that's good. And then make sure that it has the correct units. So the units here, because it is overall second order, first order plus first order gives me second order, are going to be concentration to the -1, time to the -1. My concentration unit here is molarity, so it's going to be molarity to the -1. And my unit there is seconds for time, so it's going to be seconds to the -1. So they always end in time to the -1. So 1.14 molarity to the -1, seconds to the -1 should give you that one.